Good morning, friends. Welcome to Ramsudis IAS Academy. We are back with a new video on speed, time and distance part 2. In this video, we are going to discuss concepts of relative speed, and the sub-problems in this topic are problems related to trains, problems related to boat like upstream and downstream, problems related to bus stop like a bus is moving with certain speed. When stoppages at the bus stops are included, it has certain speed, and when the stoppages without stoppages, it has certain speed. Those problems are dealt over here. And round trip problems like from A to B, it takes some time t1, and from B to A, it takes some time t2, and the ratios of t1 and t2 and speeds s1 and s2, what is the relation, that will be seen in this topic. Now moving on to the next slide, here are some basic concepts to discuss these problems. First, relative speed. Relative speed is like whenever there are two objects, be it cars, trains, or be it human beings walking. Whenever both are walking in the same direction, the relative speeds will be subtracted. Like a man is moving with 6 meter per second and another man is moving with 4 meter per second. Their relative speeds turn out to be 2 meter per second. Relative speed of both these turn out to be 2 meter per second. And next question, next in opposite directions. In the same sense, when they are walking in opposite direction, 6 meter per second and 4 meter per second, the relative speed will be 10 meter per second. Because this is, you should just remember these formulas. When they are in the same directions, the relative speed will be the difference of their speeds, and when they are moving in the opposite directions, the relative speed will be the sum of their speeds. And then boat, problems relating to boat. Upstream. Upstream, just understand the term upstream. Upstream is going against the stream, like there is a flow in this direction, and if you go against the stream, we call it upstream. And when the flow is in this direction and you move in the direction of the stream, then we call it downstream. Downstream is along the stream and upstream is against the stream. Just remember these keywords. Upstream is against the stream and downstream is along the stream. Then the formula upstream. Upstream, you just look over here. This is the speed of the stream and this is the speed of the boat. And to calculate the speed upstream, the speed of the boat upstream, the formula would be speed of the boat minus speed of the stream. And in calculating the speed of the boat downstream, the formula would be speed of the boat plus speed of the stream. Because both are in the same directions, it would be speed of the stream plus speed of the stream. And okay, you might have a question over here. This here we have added in case of opposite directions and subtracted in case of same directions. But why the opposite over here? Here, they both are completely different cases, my friends, and therefore you need not confuse over here. For relative speeds, it is difference in same directions and sum in the opposite directions, and for upstream, it is so difference of speeds, and for downstreams, it is sum of speeds. Now, moving on to the next slide. Distance. This is a basic formula which we have learned even in our previous video. Just we will make use of this formula in this video, so I have written it over here. Distance equals to speed into time. And next, stoppage per hour. These problems, this formula is for problems related to bus stop problems, and therefore I have written it over here. Stoppage per hour equals to, I'll discuss this formula then and there itself when the question arises. Moving to the next slide. Speed of the boat. This formula is regarding upstream and downstream problems. When the downstream speed and upstream speed are given, speed of the boat is downstream plus upstream divided by 2. This is a formula. You have to remember it. And speed of the stream is d minus u by 2. This is also a formula. Friends, I am not overburdening you here with this formula, but these are just the tricks to solve problems. Without these tricks, you will be ending up in a devastation. So just make sure you remember this formula. This formula make your problem solving very easy. And this formula is regarding your round trip problems. Moving from A to B takes t1 seconds and with speed s1, and moving from B to back from B to A, it would take t2 seconds with speed s2. Then the ratio of speeds s1 and s2 is equal to the square roots of t2 by t1. I think you should remember this formula, and this is not that easy, not that difficult too. The square root of the opposite ones, because speed is inversely proportional to time. When it is s1 over here, it is t2 over here. When it is s2 over here, it is t1 over here under the root. Yep. Then moving on to conversions from kilometer per hour to meter per second and meter per second to kilometer per hour. Kilometer per hour to meter per second, the multiplying factor would be 5 by 18, and from meter per second to kilometer per hour, converting, then the multiplying factor would be 18 by 5. These are some basic things which we have already learned till our class 10. So I don't need to explain you the basics, the derivations, and also I have just written the formula straightforward. So just make sure you remember this formula, and we'll move to our questions part. Question number 1. A person travels 285 kilometers in 6 hours. First part of the journey he travels at 40 kilometers per hour by bus, and the second part of the journey he travels at 55 kilometers per hour in train. Distance traveled by train is. If you remember, such sort of question we have already solved in our previous video. I just introduced the same question in this video for recollection. First step was the ratio. The time traveled with 40 kilometers per hour is k, and the time traveled with 55 kilometers per hour is 1, and the ratio I assumed it to be k is to 1. And next, the average speed is 95 by 2, because 285 kilometers in 6 hours, the average speed is 95 by 2. And here I substitute these values, 40 into k, like 40 kilometers per hour with k in k hours, and 55 kilometers per hour in 1 hour. K is to 1 is the ratio, so therefore k here and 1 here equals to 95 by 2 k plus 95 by 2. Now solving this equation, I get k to be 1 is to 1, and therefore in these 6 hours I travel both the speeds equally, because 1 is to 1, both these are equal, and therefore I travel 3 hours with 40 kilometers per hour and the other 3 hours with 55 kilometers per hour. The question asks this distance traveled by train. Distance traveled by train is distance traveled with the speed 55 kilometers per hour, and therefore distance traveled by train is 165 kilometers, and if the distance traveled by bus is asked, it is 120 kilometers. I think there should be no problem. Now moving on to the next question. Two trains X and Y start from stations A and B towards B and A. X and Y start from stations A and B and A respectively. After passing each other, they take 4 hours 48 minutes and 3 hours 20 minutes to reach B and A respectively. If X equals to 40 kilometers and Y equals, and what's the value of Y? I have already discussed the formula for such questions. This is the formula for such questions. Let me explain the question to you first. Now, from A to B, A is moving from A to B, and B is moving from X is moving from A to B, and Y is moving from B to A. The question here is, both of them have met somewhere over here. X and Y meet over here. X, Y meet over here. After meeting, X takes 4 hours 48 minutes to reach B, and Y takes 3 hours 20 minutes to reach A. That is the question, and he is asking us to find out the value of Y, the speed of Y. The formula for such problems is what I have written in the first slide, or you can also look for formula over here. Speed of X by speed of Y is equals to the square root of time of Y by time of X. This formula, there is no need for you to remember the deduction. Just remember the formula as it is, and I'll substitute the values of Sx, Sy, T2, Ty, and Tx. Sy is unknown. I have placed it just like that, and Xx is 40, and converting these speeds into minutes, like 4 hours 28 minutes. It can be converted into minutes or directly into hours. I just prefer converting it into minutes. So 4 hours 48 minutes was 288 minutes, and 3 hours 20 minutes to 200 minutes. I get the for equation to be 40 by S4 equals to 5 by 6, because the root of 25 by 36, which is 5 by 6, and S4 turns out to be 48. This is when converted into minutes. Okay, let me also show you. We yield that it yields the same answer if we converted it into hours too. Hours. The 3 hours 20 minutes is written as 10 by 3 hours, and 4 hours 48 minutes is written as 24 by 5 hours. So, and it would turn out to be root 25 by 36, and 40 by S4 equals to 5 by 6 is the equation yielded here also, and this was the same in this case too. Therefore, our Sy, the speed of Y, is 40 by 5 into 6, which is 48 kilometers per hour. You might have problems with respect to the derivation of this formula. You need not remember any such derivations. The questions of such sort will be asked directly, and therefore you can substitute those values in this formula directly and yield your answers. Moving on to the next question. Question number 3. A train crosses two men walking along the railway track at 4 kilometers per hour and 5 kilometers per hour in 10 seconds and 12 seconds respectively. Find the length of the train. Here, let us assume the speed of the train x, and here the relative speed comes into picture, and the questions from here on will be dealing with relative speeds. Now let us consider the speed of train to be x, and here in the question it is given that two men walking along the railway track. The train is moving in this direction along the railway track, and the two men are also moving along the railway track in the direction of the train. That should be understood from the question. And since they are moving in the same direction, I have subtracted the speeds over here, x minus 4, the speed of train with respect to speed of the first man, and the speed of train with respect to speed of second man. I have subtracted them over here, and into 10, this is time. This should be our length of the train, and this is also our length of the train. I think you understood this. X minus 4 is the speed, relative speed, and 10 is the time, which would yield us distance, and the distance here is the length of the train, which is equal in both the cases, and therefore x minus 4 into 10 equals to x minus 5 into 12. This is the equation we get in our next step, and on solving this, we get Rx to be 10 km per hour, which is the speed of the train. But the question asked is not the speed of the train, but the length of the train. Substituting this 10 in this formula or this form, I mean in this equation or in this equation, we'll get our answer. 10 minus 4, okay, Rx is 10. 10 minus 4, which is 6 km per hour, but this 6 is in kilometer per hour. We need to convert it into meter per second because this is in seconds, and the length of the train would also be in meters mostly because we do not find a kilometer length train, and therefore we would convert them into meter per second. And we already know the conversion factor for kilometer per hour, multiplying factor for kilometer per hour to meter per second is 5 by 18. Our answer would be 6 into 5 by 18 meter per second into 10. This is the time taken with respect to first man, and therefore our length of the train would be 50 by 3 meters. If we also consider this formula with respect to second man, so this equation with respect to second man, our answer would be 10 minus 5 into 5 by 18 into 12, which would be 25 by 18 into 12. 6 2s are 6 3s are. Our answer would be the same, 50 by 3 meters. Therefore, the answer is the same in both the cases. This is just a standard method of solving, and even this is not a big problem. This can be solved easily. And there is another trick to solve this problem. We have already seen such a problem, such a trick in the previous video too. We'll just multiply this 5 with this 12, which yields us 60, and this 4 with this 10, which yields us 40, and the extra speed, the extra kilometers, this is in distance, and this is also in distance, and the extra distance is 20, and this 20, this is excess, and this should be divided by the difference of times. I think we have also already solved a problem where the first part is traveled with certain speed and the second part is traveled with certain speed in the previous video using this trick. The same trick works over here. 20 is the excess distance and 2 is the difference of times, and our answer would be 10 km per hour, which is the speed of the train. And from here it would be similar to the previous case. And therefore, if this trick is confusing to you, you can go ahead with this method, which is easy too. Moving on to the next question. Two trains are running on parallel lines in the same direction at a speed of 50 and 30 km per hour on a parallel lines in the same direction. The thing that should strike to you is it should be the relative speed should be the subtracted ones, and 50 km per hour and 30 km per hour. The faster train crosses a man in slower train in 18 seconds. The length of the faster train is. Here there are two trains moving in the same directions. This is the faster train, this is the slower train, and there is a man sitting in the slower train. The question asks this faster train, how much time would it take to cross? Here, in case of train problems, crossing is when the head of the train crosses the man and the tail of the train also crosses the man. It is meant by crossing. When both the head and tail cross, the head and tail of the train cross the man, then it is man or pole or platform. It is called crossing in train problems, and therefore the time given 18 seconds is the time taken for the entire body to cross this man. So the length of the train would be speed into time. Speed here is the relative speed, which is 50 minus 30, 20 km per hour, and mostly the length of the train will be in meters, and therefore I have converted it into meter per second by using my multiplication factor 20 into 5 by 18 into the time taken 18 seconds, and therefore my length of the train would turn out to be 100 meters. Most of the questions would be of similar sort. In case of a man, you will generally have a platform where a man has a negligible length and therefore it is neglected. In case of platform, you will add both these. You will see such problems in in the coming slides too. Do not worry. Then problems related to boat. A boatman goes 2 km against the current, which is upstream, and in 20 minutes and returns in 15 minutes. Returns is in the opposite direction, which is downstream. In 15 minutes, find the speed of the current. Upstream speed from our form, okay, I will directly substitute our distance and time over here, 2 kilometers and 20 minutes. We will convert it into hours, and our upstream speed is 6 km per hour, and our downstream speed, substituting the values of distance and time, would be 8 km per hour. Therefore, find the speed of the current. The speed of the current has a formula too, which we have discussed in our starting slides, which is d minus u by 2, which is 8 minus 6 by 2, 2 by 2, which is 1 km per hour. and therefore we found our answer. If speed of the boat is being asked, we also have our formula from the first slides, which is d plus u by 2, which is 8 plus 6, 14 by 2, which would be 7 kilometer per hour. I think this should be easy. No need to worry questions related to boat and boat like upstream and downstream problems, and questions related to trains, my friends. Just make sure you understand the question perfectly and then go ahead with solving the solution. Then a person rows a boat in still water at a speed of 15 km per hour. Speed of the boat is 15 km per hour is given in the question. He can travel twice as much as row upstream and than downstream. Here it is twice. He takes, here the twice implies as much as row upstream than downstream. This is distance given over here. In the time taken to travel upstream, in the same time he can travel twice the distance downstream. That is what he meant over here. And since distance, speed is directly proportional to distance, in the question he gave upstream, if he travels upstream with the distance, a distance d, downstream he travels a distance 2d, and therefore upstream speed is half of downstream speed, or downstream speed is twice upstream speed. I think this should be clear from the question. And speed of the boat from our starting slides would be d plus u by 2. And the d from the question is d equals to 2u, because twice as much as row upstream he rows downstream. Therefore, this substituting 2u in this formula, we get 3u by 2 equals to 15, and our u turns out to be 10 km per hour, and d turns out to be 20 km per hour. He is asking us to find the speed of the current. Speed of the current is d minus u by 2, which is 20 minus 10, which is 10 by 2 equals to 5 km per hour. Every other question can be solved on similar lines, my friends, so need not worry. Just keep practicing problems with related to boats, and then moving on to the next question. A person running at 7 by 11 of his usual speed reaches a place in 22 hours. His usual speed could save him x hours. This is not much a difficult question, and this doesn't even require speed, time and distance. This was just a question to test your solving skills. I'll just assume the usual speed to be 11 km per hour, then 7 by 11 of his usual speed would be 7 km per hour. The time taken with this 7 by 11 of his usual speed is 22 hours, and therefore the assumption I made is 7 km per hour, and therefore the distance for my assumption would be 154 kilometers. I mean, in 7 hours he would be covering say 154 kilometers with with 7 in 22 hours he would be covering 154 kilometers with 7 km per hour speed. And with his the time taken for his usual speed, which is 154, the distance by speed, which is 154 by 11 km per hour, this is his usual speed, would be 14 hours. Usual time would give him 14 hours, and in this special case he would take 22 hours. The question asked is, it would save him x hours, and what is this x? It would save him 22 minus 14, 8 hours, which is our x, and this is our answer. Moving on to the next question. Excluding stoppages, speed of bus is 54 km per hour, and including stoppages, it is like a bus stops a bus starts from A to B, and there are 3 bus stops in between. Whenever a bus stops here, some amount of time is wasted, and therefore its speed decreases. When there is no such stop, its speed would be constant, a higher value, and that is what given over here. Excluding the stoppages, its speed is 54 km per hour, and including the stoppages, its speed is 45 km per hour. For how many minutes per hour the bus stops at its bus stop? He's just asking, per hour, how many minutes does it stop at all these bus stops summed up together? Per hour, how many minutes will it be wasting in bus stops? From the formula which we have learned in the starting slides, it would be time equals to faster speed minus slower speed by faster speed. Faster speed is 54 km per hour, slower speed is 45 km per hour by faster speed, which is 54 km per hour. This is excluding stoppages, this is including stoppages. Into 60 minutes, this would always be minutes. This is a formula which is deduced in some books, and I have directly taken it from the books. You need not worry with respect to the derivation and all. Just start practicing problems with this formula. Yep. And substituting these values, it would be 9 by 54 into 60. On cancellation, it would give me 10 minutes. The bus stops 10 minutes per hour in these bus stops. Not each bus stop, all the bus stops together, it would stop 10 minutes per hour. It is 10 minutes per hour because it is asked in the question per hour. Now, moving on to the next question. These are a level ahead, problems level ahead with respect to train problems for relative speed. These are higher level problems, and so I'll start these problems I'll solve these problems too in this video. A and B are 285 kilometers apart. A train starts from A at 9:30 a.m. and travels towards B at 60 kilometers per hour. Another train starts from B at 10:30 and travels towards A at 40 kilometers per hour. What time will they meet? Just make sure you understand the question. Train A starts at 9:30 a.m. Train A starts at 9:30 a.m. from A and travels towards B with 60 km per hour. And from point B, train 2 starts at 10:30 a.m. with 40 km per hour towards A from from B to A. The question asked is what time will they meet? Now, at 9:30 a.m. it is at A and at 10:30 a.m. it is at B. We cannot calculate the distance between them because the times are different. We can only calculate the distance between them at a single point of time. So let me calculate the distance between them at 10:30 because 10:30 the train is over here and 10:30 the train 1 would be over here, which is 60 km from its starting point because in 1 hour it would travel 60 km per hour because 60 km because its speed is 60 km per hour. And therefore 60 kilometers is covered by train 1 from A and at 10:30 it is 60 kilometers ahead of its source and the remaining distance is 225 kilometers. And what time will they meet? Time to meet equals to, I have written it over here, yeah, time to meet equals to distance, the remaining distance, the distance between them 225, it is at B and it is over here, this distance is 225 and the distance between them by the relative speed is 60 plus 40 because they are moving in the opposite directions and therefore 60 plus 40, 225 by 100 which is 2.25 hours which is 2 hours 15 minutes. He is asking at what time. From 10:30 they started and from 10:30 2 hours 15 minutes ahead they will be meeting each other which is 10:30 plus 2 hours 15 minutes which is 12:45 p.m. they will be meeting each other. Moving on to the next question. This is question on similar lines. Abhinav leaves Mumbai at 6 a.m. and reaches Bangalore at 10 a.m. Praveen leaves Bangalore at 8 a.m. and reaches Mumbai at 11:30 a.m. What time do they cross each other? This is a question on, solved on similar lines. I think you should be able to solve this. I have given the solution for you. I am not going to discuss this question for you. Just pause the video, solve this question, and in case you have any doubt, just refer to this solution. Moving on to the next question. A train crosses a platform in 60 seconds at 45 km per hour. How much time does it take to cross an electric pole of electric pole? Length of platform is 100 meters. Now, a train is crossing a platform. It means that the head of the train crosses the platform and the tail of the train also crosses the platform. First, the head of the train is over here and this moves this way, and in the final stage, only after the tail of the train crosses the platform, it would be considered train crosses a platform. Then, moving to our solution part, it would take 60 seconds to cross the platform. Length of the train plus platform is speed into time. Our speed is 45 into 5 by 18 because it should be converted into meter per second into 60 is the time. Our length of the train plus platform is 750 meters and the length of the platform is given to be 100 meters and therefore the length of the train is 750 minus, this is minus 100 which is 650 meters. The question asked is, how much time does it take to cross an electric pole? This is an electric pole and this is an electric pole and then the train is crossing, just its head and tail both are crossing. What would be the time? The distance is 650. Distance here is the length of the train which is 650 by speed which is 45 into 5 by 18. It would yield us 52 seconds. Therefore, 52 seconds is the time it takes to cross an electric pole. The next question. Two trains A and B start to move from Patna to Delhi 6 a.m. and 6:30 a.m. respectively at speed 60 km per hour and 90 km per hour. How far from Patna will they meet each other? Now, from Patna to Delhi, train A is moving at 6 a.m. Train A starts moving at 6 a.m. with 60 km per hour and train B at 6:30 a.m. with 90 km per hour speed. He is just asking us, after at what distance from Patna will they both meet? Now, both are different points of time, so the distance between them cannot be calculated. We'll just find the distance of A at 6:30 because at 6:30 we know the distance of B. Now, 6:30, A would be 30 meters ahead of Patna and B would be at Patna. Now the distance between them is 30 kilometers because in half an hour A would travel 30 kilometers because its speed is 60 kilometers per hour and in half an hour it would be traveling 30 kilometers per hour. And the distance between them is 30 kilometers and the relative speed is 90 minus 60 which is 30 because both are moving in the same directions. A is moving in direction from Patna to Delhi, B is also moving from direction Patna to Delhi and therefore relative speed would be subtracted. Therefore our time at which they meet is 30 by 30. 30 is the distance between them and 30 is the relative speed. which would be 1 hour. They would be meeting after 1 hour from 6:30, because it is calculated from 6:30. They would be meeting 1 hour after 6:30. So the answer would be from 6:30, A would travel 60 kilometers in 1 hour, because they would be meeting in 1 hour. It would travel 60 kilometers in 1 hour. By 7:30, it would be over here. Therefore, distance from Patna to this point, 7:30, is 90 kilometers. Or in 1 hour, this train B would be traveling 90 kilometers because its speed is 90. And at 7:30, it would be 90 kilometers ahead of Patna, and therefore our answer is 90 kilometers in both the cases. Our answer is 90 kilometers. You need not solve for both the cases. In any one case, if you yield an answer, it would be the same in the other in the other case too. I'm just showing you that the answer would be same in both the cases. Moving on to the next question. Okay, we are done with the questions today. And I think all the problems here were understandable to you. So make sure you practice problems of such sort without neglecting any problem, and you'll be successful in attempting questions with respect to speed, time, and distance. Thank you, my friends.